video shows how to use FFTs on Keysight Infiniium scopes. Anytime you walk up to an instrument, you should do a default setup or a factory default setup. This can easily be accessed from the control dropdown to default setup, or there is a button on the front panel for a default setup. For this video, there's a 10 megahertz sine wave coming into channel 1, and one typically wants to use up most of the screen to capture the signal. Otherwise, you throw away dynamic range. So we'll scale the waveform. That's a little bit too much. You want to use just over 7 divisions, so that's probably good right there. To turn on an FFT, it's very simple. We go to the Math drop-down, select New FFT, and I can select, in this case, Channel 1. This will turn on a second window, and here's my FFT down here. And we'll notice that we have spectrum analyzer-like controls: start, stop, center frequency, span, and RBW. There's also a preset button and mark peaks. Since this is a 10 megahertz sine wave, I'm going to set stop to 20 megahertz. And we notice that we have a very broad central peak. So it turns out this is a very clean sine wave, but it's a simple matter to change the resolution bandwidth to get better frequency resolution. Essentially what this does is it increases the time capture. Okay? It automatically adjusts the sample rate and memory depth and screen width to get a better resolution in the frequency domain. The frequency resolution basically goes by 1 over your time capture, and this is also affected by the window type. So if we keep increasing the resolution bandwidth, I'm going to decrease the scale a little bit or increase. If we keep increasing it, we'll notice that the FFT noise floor drops down, but we also see that the sample rate can change. A lot of times this is not necessarily a good thing. So we can control the sample rate either by clicking on either the memory depth or the sample rate, or set up acquisition. And here we can set the sample rate to manual, and now it will not change. It's probably a good thing to leave the memory depth to automatic. I'm going to leave this at 10 gigasamples. So now when I change the resolution bandwidth, the sample rate does not change. Okay? But as you go to more and more points, the longer it takes the FFT to process. Now, however, I may wish to see a few cycles of the sine wave and have a very small or good narrow resolution bandwidth. We can do this by going to the Measure dropdown and selecting Setup and Measure All Edges. And depending on the software revision of the scope, it may say Measure All Data. Check that. And if I change my time scale now, I still muck around with the RBW. So what I really want to do is go back into the acquisition menu, set the memory depth to manual, and bump it up. And now the FFT is processing off-screen data as well. So I can zoom in on the time domain and still get good frequency measurements. However, the RBW control in this scenario is disabled. So now let's take a look at a few basic FFT features. I also have a preset button, but I have a nice mark peaks button. So I get this new line here. It's the peak level. Okay, and this defines a peak. So if I bring it way down here, okay, it's going to put some additional peaks here. It's identifying essentially noise peaks. So I want to use this to control my peak level. Okay, and I've got one, and it tells me 9.99 megahertz, 8.46 or so dBm. If I right-click here, I can select Setup Callouts and hit FFT peak callouts, and now I can drag this around, and it will auto-identify several peaks. So maybe now I want to zoom in on it, so I can simply mouse over span, and I can either type something in by clicking on it, or I can mouse over it and use the mouse wheel or the arrows and bring it in here. Now again, notice that if I change my time scale, does not affect the FFT resolution. And there are some off-screen peaks. All right, so obviously I have harmonics that are off of this screen here, off of the FFT window, and it's giving me those relative power levels. Okay. At this point, I want to note that if we simply click on F1 or right-click on the waveform and go to function 1, either way, we'll bring up the FFT menu. So here I again have some other good things, such as the window type, rectangular handing, flat top, Blackman-Harris, Hamming, and so forth. If I want to know more details about this, I can simply click on the help icon, and it'll bring up the relevant help menu. But really I want to go to FFT functions, and here it'll tell us what the window functions do, and so forth. But also important is I can change how many peaks I have in the mark peaks function, and this is an alternate control for the peak level bar, additional the same horizontal controls, and I can also change it into linear scale. One thing that's worth noting is that this reference level is, unlike on a spectrum analyzer, which is typically at the top of the display or screen, for FFTs on the Infiniium scopes, it is at the center screen. So just bear that in mind if you're a spectrum analyzer user. So I want to take a look at, say, max values, min values, and so forth. I don't really care about the time domain anymore, for example, so I'm going to go to Display, Windows, and Tabbed Custom Window Layout. And now I've got I can click back and forth between the frequency domain and the time domain, and or I can pull them apart and put them wherever I feel like, or whatever. But I'm going to leave them tabbed like this. So what I want to do is I want to have a max and min and FFT average. Okay, so I'm going to right-click somewhere away from the waveform in the grid and go number of grids. I'm going to turn on 3, and they all show up in this FFT window. And let's just stop the scope. So I can go to Math and Functions, okay, or I can hit the plus button near the channels, go to Function 2. So I want to do a max, and I need to select Function 1. So that's my FFT. And again, I get a similar window. Turn that on. And we notice it automatically shows up in this lower grid. F3, Math. Again, I want to do min, Function 1. Turn that on. And now finally, F4, Math, and should show up under Average, and Function 1. And now I have very similar overall controls, peak counts and so forth, number of averages. This is not average acquisition mode. This is only an average of function 1. Simply turn that on. Great. So it actually added 4 windows, and they all have very similar displays. So I have start, stop, center frequency, and so forth. If I wanted to change channel 1, I simply click on channel 1, and now these controls are color-coded to channel 1 and so forth. I could even make some measurements. So right-click on time measurements and select pulse width. Say drag it over to my average. It gets color-coded. And now I see that it's a 5.9641 kilohertz width at an 894 hertz resolution bandwidth. Of course, this is in linear scale. This is not the 3 dB point, so just bear that in mind. I could do a max. Maybe I'll put this on my max. So I get Vmax at about 8.5 dBm. And it's also worth noting that if I go back to width, I can do right-click and track with markers. And so it shows me where the measurement was made, which is nice. And one of the things I'd like to show is I'm going to go back to channel 1, and I'm going to increase that span quite a bit. Wrong way, of course. All right, and I have these tones. I'm going to turn off mark peaks, and I'm going to go to measure markers, and I'm going, instead of selecting track measurements or off, I'm going to select track waveforms, put them on channel 1, or function 1, excuse me. And now the markers, as I drag them left and right, will track the waveform. So for example, whoops, I grabbed the channel itself. There we go. Here's my X1 marker. And I can stick it right on this peak, for example, or at least very close. I can grab X2, get it up on this peak, and I can measure things like the distance between peaks. I want to show that we have some additional FFT built-in measurements, and really I don't need these other channels. I'm going to turn them off, which is easy. I just click on this plus button, turn off F2, F3, and F4, and I don't want these grids. I can just close them out, and now I will go to Measure, Add Measurement, and on the left column here, we have different types of measurements, spectral, eyes, and so forth. So if I select spectral, I get some FFTs. And what I want to measure is maybe FFT frequency. Okay, so I get another peak level, which doesn't have a line, peak 1 and peak 2. And I think if I set this to, say, minus 57, this will be dB again. And okay, so I got some measurements. What are they? So let's again right-click, select track with markers. There they are. I can see that, you know, between the tones, I've got just under 10 megahertz or 10 megahertz and about 53 dB. And I think if I slide the waveform off so that this main peak is excluded, I can just drag it like that. Oh, how about that? It's still measuring all data. So what I can do is I can right-click, edit measurement, peak 2 to peak 3. So I didn't have to slide it off, and here I go. Again, I can repeat that. Edit measurement, peak 3 to peak 4. And this illustrates a good point, is that this peak is below that threshold level I defined, so it doesn't get counted. A few final things to show. I'm going to switch back to the time domain and turn on channel 2, where I have a relatively slow square wave on. And let's turn off channel 1. So I've got a reasonable looking square wave here. Now what I can do is I can actually do a gating math function. I switched to this mode, and I can do horizontal gating channel 2. And let's just do function 5. Okay. And so I end up with kind of this zoom box. There's another video on zooms. Now, the main point here is that I can FFT only this section, which is pretty cool. So I might do yet a third window. And now, I don't want to see F5. I want to do an sixth function. And I'm going to do an FFT on that gate. This might be useful for looking at only a small slice of spectrum of a small slice of time, for looking at spectral noise on the top or bottom of a square wave, or other things of interest like that. Turn it on. Of course, the drawback in a use model like this is that I don't have a ton of time capture, but I can do a gated FFT, is the main point there. Further, if I wanted to filter this, what I would do is I would disable F6 and then change it such that it is a filter. So I could do, for example, a high pass and a low pass filter. So I would chain these together. So a high pass filter, 350 megahertz. I don't have to turn it on. Now I go F7, all right, filter, do a low pass filter. So I want to go lower than that, obviously. So let's imagine 100 megahertz, for example. And this would be of function 6, since function 6 is my high pass filter. And then finally, for function 8, I would go FFT of function 7. If I turn this on, probably get a fairly ugly response, but that's not the point. And if I click on this summary button, I can also see what everything is, and it gives me a check mark if everything is makes sense, because it is possible to do math function chaining that doesn't make sense. And that concludes basic FFT usage for Infiniium scopes. Thank you for your attention.